All right, we can move into section 4. Just wanted to give some highlights onto what some attacks would look like on the packet capture and Wireshark. So starting with one of the attacks that we've talked about, the SYN attack. If you notice, all of the packets here are all SYNs. And what we're doing here is we have an attacker who is spoofing SYN packets from a variety of sources. If you can see here, these are all different source IPs, all going to the same exact destination IP. This destination IP is what we are trying to attack and essentially DOS, perform a denial of service on. So the attacker is going to spoof all of these SYN packets. They're going to go to the victim machine of the .159, and what's going to happen is this server is going to reply and become overwhelmed with the amount of SYN-ACKs that it wants to establish back, because if we remember our TCP three-way handshake, we had SYN, SYN-ACK, and ACK. So when the attacker sends all these SYN packets, the victim machine is really going to be overwhelmed with the sheer number of SYN-ACKs that it's going to try to keep up with for all of these people that are trying to start a conversation with it. And one more thing I want to point out is if you look at the timestamp here, this is all within, we're not even going up to another second here. This is all millisecond, I don't even know, hundredths of a second breakouts. So it's kind of unfathomable to understand how fast this is actually happening. And all these screenshots that I'm taking, definitely be sure to look at the links that I post here if you want to go read about the post that they made or have more additional information on it. But high level overview, the SYN attack, you're going to have the same destination scene. You're going to have a bunch of SYN packets all going to the same destination from a variety of source IPs, all within a really short time span of each other. And the victim machine is going to be DOS because it's not going to be able to have the resources to be able to reply to all of the hundreds of thousands of SYN-ACKs to keep that connection going. All right, the next attack that we talked about Smurf and Fraggle. I'm just going to give the example of Smurf here, and this is using ICMP ping messages. So we have this attacker who is going to send a spoofed IP address. So in this example, the source is the .103. This is obviously not the attacker's IP address. The .103 is the target machine's IP address that is being spoofed by the attacker. The attacker will send this ping request to the broadcast address of the network. As you can see here, the destination is the broadcast IP address for whatever subnet or network this is working out of. And by sending this packet for a ping request to the broadcast, that means all of these clients are going to need to respond with a echo reply to the ping to be like, yep, I'm up. And it's not going to be directed to the attacker's box because he spoofed the IP address. It's going to be sent to the spoofed IP address of .103, which is the victim machine. So what it looks like over the wire, again, notice the timestamps, crazy fast packets going, all from a spoofed source IP by the attacker. So this is the victim's IP address, all sent to the broadcast IP address of that network, and the ping requests are going out. And when these clients all respond back with a ping, an echo reply message to confirm that they are up, this machine is going to be DOSed because it's going to be completely overwhelmed with the number of packets that are inbound to it. So that is the Smurf attack, and remember the Fraggle just dealt with the same exact concept except using UDP packets instead of ICMP. All right, ARP scanning. The purpose of ARP scanning is to discover the network topology and identify devices that are connected to the network. So ARP scanning, port scanning, I definitely wanted to cover these. Again, make sure you check out the resources that I'm posting here for where this nice screenshots of Wireshark are coming from, and be sure to read their blog posts. The time, crazy, down to hundreds of milliseconds here. We're not even at 1 second yet. The ARP scanning is basically the attacker sending to the broadcast address for the network to see if any IP address is up. So if you can notice here, it's incrementing sequentially by 1. It is going to hit every single IP address within the network, and the attacker doesn't know what IP is up or not. It's saying, is 78 up? Is 79? Is 80 up? If so, tell 192.168.204.20, which is the attacker machine or wherever they're sitting. So if the attacker gets a reply for, hey, who has 192.168.204.78, and the 78 replies with, oh, that's me, this is my MAC address, the attacker knows that that machine is up. It doesn't really know if any of these IPs are up. It's only waiting for the reply to say, yes, I am up. If it doesn't get a reply, then it assumes the device is not up. So that is how they're able to identify devices that are connected to the network. Just a straight shot sequentially through all the IPs that exist, sending it to the broadcast and looking for that reply of the MAC address to be like, oh, that's me, or not. And then they know if the 81 replied with a MAC address, that box is available to attack or perform next steps with. So ARP scanning, not too bad, and just a good example to show what it looks like in Wireshark. All right, an ACK push. This is a flood type DOS where the attacker sends a large number of TCP packets with the ACK, the acknowledgement, and the push flag set with the goal of overwhelming the target system resources, making it unavailable to legitimate users. So what happens here is if they send an ACK push flag, the victim is going to respond, it may respond with a reset flag in attempt to terminate the connection. So why would the victim machine reply to an ACK push with a reset? Well, if you remember, TCP, we care about our connections, going to be looking for that initial TCP three-way handshake. And if it's not tracking that it ever had a conversation with this box, this attacker's box, and this is now sending an ACK and a push of data to the victim machine, the victim machine is going to be very confused. It's going to say, wait a minute, I don't remember having a connection with you. I didn't establish a three-way handshake with you. We should close this connection. So they send a reset flag. So if the machine is not tracking a connection, it's going to be like, I don't know what you're talking about, reset. And what happens here is the victim machine becomes completely overwhelmed with the number of push ACK flags that are sent to it, that it can't keep up with the number of reset flags that it needs to set, denoted by the packets in red here. So it essentially gets DOSed because it cannot keep up with trying to close out all of those connections. So again, more information on the ACK push flood and essentially being DOSed by trying to close out a bunch of connections that it wasn't tracking it was ever having because, well, it didn't. Port scanning. I would definitely be familiar with port scanning. So the most important thing to take away is the response that you get for if a port is open or if a port is closed. When you start port scanning, you're going to pick a device on the network and you're going to say, is this port open? And like the ARP scanning to see if a device is up by going one IP at a time through the entire network, this is going to go through every single IP or port one at a time, port 1, 2, 3, 4, 5, 6, maybe 22 is open. If it gets a SYN-ACK back, that would be bad news bears for that device. Maybe 23 is open. Maybe 3389 is open for RDP. If the attacker is scanning the device for every single port to monitor for the responses of SYN-ACK or reset, the attacker can determine what port is open on that device. So kind of what it looks like in Wireshark, we have a SYN sent in the gray packets here to be scanned for that port, and if the port is closed, you'll get a reset or a reset ACK here. So all of these ports are coming back closed with all of the initial SYN packets sent. So this is the closed box here. If a port is open, you'll see that the SYN packet goes out and the reset ACK comes back, but this one, a SYN ACK, came back. So this port, for whatever port it was scanning, is actually open. So the attacker would know, hey, this port is open and it's available for use to try and attack or further escalate whatever part of the cyber chain they're in. And then there's also filtered, which is no response, which means the port is potentially open, but the firewall is blocking the response, so it could be filtered. So a good demonstration here. Be sure to check out the blog resource here and read more about port scanning.